Okay, so this is going to be Chapter 8, Lesson 5, Part 2. So we stopped with number 10, which was just like number 21. This time we're going to look at number 11. Number 11 is just like number 22. It says, which of these symbols greater than, less than, or equals should go in each of the following? So for Part A, we have 10 to the 5th, and then we have 10 to the 5th squared. And we need to figure out what symbol goes here in the middle. Well, 10 to the 5th squared, remember that's raising 10 to the 5th to the second power. When you raise a power to the power to a power, that means that you multiply the exponents. So what we have on the right here is actually 10 to the 10th. And what we have on the left is 10 to the 5th. So it's easy to see that the number on the right is bigger. So 10 to the 5th is less than 10 to the 10th. So the symbol that we should have here is a less than sign. Okay, Part B. Part B has 10 to the negative 5, and it also has 10 to the negative 5 squared. Okay, again, we're raising a power to a power, and when we raise a power to a power, that means we multiply the exponents. So 10 to the negative 5 squared is the same as 10 to the negative 10. Well, if you compare 10 to the negative 5 and 10 to the negative 10, you can tell that 10 to the negative 5 is going to be bigger. 10 to the negative 5 is 0.00001, where 10 to the negative 10 is 1. So you can tell that 10 to the minus 5 is much bigger than 10 to the minus 10. So greater than is the symbol that we should use. For part C, we have 6 times 10 to the minus 4, 6 times 10 to the minus 4. And then we also have 7 times 10 to the minus 4. Well, we can put both of these in decimal notation. We're starting with a 6, and we're going to move our decimal 4 places to the left because it's a negative sign. 1, 2, 3, 4. So 0.0006. And then our other number, we're starting with a 7, and we're going to move the decimal 4 places to the left. 1, 2, 3, 4. So we have 0.0007. So you can see that 7 times 10 to the minus 4 is going to be bigger than 6 times 10 to the minus 4. So our symbol is going to be a less than because 6 times 10 to the minus 4 is less than 7 times 10 to the minus 4. Okay, we're going to do just one more from this problem. Let's look at part E. Part E has 8 times 10, times 10 to the negative 10. And it also has 80 times 10 to the minus 11. Well, our number on the left is in scientific notation and our number on the right is not. So let's move it to scientific notation. Changing it to scientific notation, we would put our decimal right here. So that's an 8 times 10 to some power. What power is it? Well, to change the 8 back to an 80, we would move our decimal 1 place to the right. That's moving 1 in the plus direction. So what we're going to do is take this negative 11 and add 1 to it. Negative 11 plus 1 is negative 10. Okay, so 80 times 10 to the minus 11 is the same as 8 times 10 to the minus 10. That means that we need an equal sign. So again, number 11 is just like number 22. Now, if you do not remember while we were in class, what I recommended that you do before you start working on these problems is go to pages 382 through 383 and copy down all of the exponent rules onto a note card that you have next to you while you're working through these problems so that you don't forget how these work. All of these rules are x to the a times x to the b equals x to the a plus b. That's the first one. Then we have x to the a divided by x to the b is equal to x to the a minus b. That's an a, not a 9. We have x to the a raised to the b power is x to the a times b. We have our special rules that x to the 0 is equal to 1, and x to the minus a is equal to 1 over x to the a. And then we have our, the next rule we learn in the next lesson. So I do recommend that you copy down all the rules that are on those pages so that you don't forget what they are while you're working through other sections in this chapter. Okay, new page. So we worked through number 11. The next thing we're going to work through is number 12. Number 12 is just like number 23 that I assigned for homework. So find the products and quotients, express each answer in scientific notation. This means you're not done until the answer is in scientific notation. So we're going to do part B first. Part B has 8 times 10 to the 6th multiplied by 5 times 10 to the minus 6. Okay, the way that I recommend you work these is multiply your straight up numbers first and then multiply your powers of 10. So I'm going to rearrange this to be 8 times 5 times 10 to the 6 times 10 to the negative 6. So you'll notice that I rearranged the order because I moved the 8 and the 5 next to each other. And then I moved the 10 to the 6 and 10 to the negative 6 next to each other. And I also changed what the parentheses were going around. That's because we are doing just multiplication here. Everything is being multiplied. And multiplication is both associative and commutative. That means that we can change the order and we can change where the parentheses are. So let's do this multiplying. 8 times 5 is 40. 10 to the 6 times 10 to the minus 6. We're multiplying numbers with exponents. That means we add our exponents. So we have times 10 to the 6 minus 6 because we are adding 6 and negative 6. So this is 40 times 10 to the 0, and that's just 40. But that's not scientific notation. For scientific notation, we need to put a decimal here between the 4 and the 0 because we put our decimal after the first non-zero digit. So this is going to be 4 times 10 to some power. What power do we need? Well, if we move our decimal here to just after the 4, that means that we're going to have to move our decimal over one place to the right to get the number we started with. So it's 4 times 10 to the 1. Okay, the next one we're going to work with, I'm going to get a new page, is 12D. 12D is 8 times 10 to the second power divided by 4 times 10 to the negative 5th power. And what I'm going to do is split it up like this. I'm going to say 8/4 times 10 squared divided by 10 to the minus 5. Division and multiplication are both associative and commutative. Well, I have to take that back. Multiplication is associative and commutative. Division is not. But I can divide it up this way. So 8 divided by 4 is 2. 10 squared divided by 10 to the 5th, that is 10 to the 2 minus a negative 5. Notice that changed our negative to a positive. So this is going to be 2 times 10 to the 7th. Okay, that's all that we're going to do for number 12. Remember, number 12 is just like number 23. Okay, so the next thing we're going to look at is number 13. Number 13 is just like number 24. Number 13 says we have 2 times 10 to the minus 5 centimeters. That's the smallest living thing that can be seen with an ordinary microscope. And they want us to write this number in decimal notation. Okay, so we're going to start off with the 2, because here we have a 2. And then it says times 10 to the minus 5. That means we're going to move 5 places in the negative direction. The negative direction is to the left. So we're starting off here after the 2, and we move 5 places to the left. 1, 2, 3, 4, 5. So we're going to fill in these spaces with zeros and then put a decimal here. So it's 0 point and then 4 zeros and then a 2. That is what the number looks like in decimal notation. Okay, so now we are going to move on to number 14. Number 14 is like number 25. For number 14, we are given 2 numbers. The General Sherman tree, which is a giant redwood in California, weighs 4 million pounds. So here is, sorry, that's a comma. 4 million, and that's another comma. 4 million pounds is how much that tree weighs. It grew from a seed that had a weight of, and this has 5 zeros, 1, 2, 3, 4, 5, and then a 1. So that is 1/100,000th of a pound. Or 1/1,000,000th of a pound. I have to see. 1, 2, 3, 4. 1/1,000,000th of a pound. Part A says to write each of these numbers in scientific notation. So to write 4 million in scientific notation, we're going to need to put our decimal right here after the 4. So I'm going to start off by writing 4 times 10 to some power. Always go ahead and write that times 10 because you're always going to have times 10 to some power in scientific notation. Now, how many spaces do we have to move our decimal to get back to our original number? Well, this is 6 spaces, so it's 4 times 10 to the 6th. Now, for our other number, putting it in decimal into scientific notation, we need to move our decimal to just after our first non-zero digit, which is 1, times 10 to some number. What number is it? Well, going from where we moved our decimal to, we have to move our decimal 6 places to the left. To the left is in the negative direction, so that means times 10 to the negative 6. So these are two numbers in scientific notation. Part B says, how many times heavier is the tree now than it was than the seed from which it grew, which is this weight. So for part B, we're going to take 4 times 10 to the 6th and divide it by 1 times 10 to the negative 6. So we can split this up into two problems, 4 divided by 1 and 10 to the 6th divided by 10 to the negative 6. So 4 divided by 1 is just 4. 10 to the 6th divided by 10 to the negative 6 is 10 to the 6th minus a negative 6. Remember, when you subtract a negative, that's the same as adding. So we get 4 times 10 to the 12th. And that is how many times greater or how many times heavier the tree is now than the seed from which it grew. So this is number 14, which is like number 25. And that is all for Chapter 8, Lesson 5.